topic is ice cores, climate, and Noella, as you can see. She's got a lot of fine academic work behind her. So she's a professor of engineering at the Thayer School. She's the executive director for the U.S. Ice Drilling Program Office. Mary got her BS in mathematics from Penn State and a BE and MS in engineering from Dartmouth College. And a PhD in applied mechanics and engineering science from the University of California, San Diego. She was the chair of the U.S. Committee of the International Polar Year, which was 2007-2008. And she has led and participated in many scientific expeditions, both in Greenland and Antarctica, most recently as chief scientist on the Norwegian-U.S. traverse from the pole station to the South Pole. And my favorite claim to fame is that there is an Albert Valley named after her in Antarctica. So without further ado, I'll leave it there. Thanks for being here.
Thanks for having me. And I'm excited to be here. The Sierra Club, I thought you might be interested in the environment, but I figured I would just start out with my electric bill. We just got our bill last week, and the total bill has a negative sign in front of it, and it's like negative $60. This is something that I think the people like you are well aware of and have long known about renewables, but the power that they have now, they're becoming more and more affordable. It's almost to the case now where we can't afford not to have it. You buy it, it costs less than a new car. It pays itself off in 7 years. The solar panels are guaranteed for 25 years. And after 8 years, the electricity is free. What's not to like about that? You cannot afford not to go solar. So that's the wallet part, but I'll start and we'll get back to the wallet. But in communication of science, we always start from this way, from going the environment and climate and end up at, oh, and it's cheaper too. But for a lot of people, the oh, it saves you money is what they would hear and what might make them move on things. So thanks. So all right. So I'm just gonna, here's an overview of the talk. I'll try not to drag on too long, but start out with change, climate change. It's hard for people to envision. We're going to talk a little bit about how fast climate can change from evidence in the ice cores. How do current conditions compare with the past? And ice core evidence showing that both policy and economics matter to what ends up in the Greenland ice sheet. Money impacts human behavior. This is where I get to the wallet part. I think it's money that impacts the human behavior. And we're living in a time of opportunity for renewable energy. And individual actions matter. You hear about people saying, oh, what can one person do? Oh, it's too small, it doesn't matter. It does matter. So change you can believe in. We live on the earth, we are so used to hearing the seasons, the summer, fall, winter, and spring. But when you think about it, how dramatic a change that is. The summer, we have to cool our homes, we wear an entire different wardrobe than we wear in the winter. Winter comes now, we have to heat our home, we have to wear different clothes. Instead of mowing the grass, we're shoveling the snow. This is really different environmental conditions. But nobody thinks about that because we are so used to it. Ever since humans have been walking and talking, there have been seasons, and people understand that. They're used to it. It's a kind of change that they can believe in. But we know from the greenhouse effect now, putting the greenhouse gases into the atmosphere, carbon dioxide, causing the planet to warm as a whole, that it's changing the climate where we live. It's changing our climate now, and it has been changing it for a while. In the polar regions, this is a picture of Don Perovich up in the Arctic, but the change has been very vivid. Because ice is very close to its melting point, even under cold conditions from a material science point of view, when a temperature changes and it changes phase from ice to water, it makes a difference that you can see right off. And we know that from the receding sea ice in the Arctic, from the melting glaciers in the Arctic and the Antarctic, the changes there are very, very vivid. But even in Hanover, the plants have known, they have sensed for a long time that change has been happening here too. This is, we buy our seeds. Here's a typical seed packet, and probably most of you have gardens now. On the back of the seed packet, there's a map of the planting season that tells you when to plant your seeds so that it'll grow well. Well, did you realize that in 1990, the map looked like this? A lot of blue space up here. And in 2006, you notice how these growing zones have moved north. This is climate change. It has been happening since well before 1990, but it's been creeping up on us. If you haven't, looked at your seed packets every year and thought about them in detail, you might not have noticed this, but it has been happening. The Earth is a system of systems, so that when our Earth warms, the planet warms as a whole, we don't expect it to warm the same amount everywhere. On a scale of days and weeks and months, the atmosphere blows around the world. The rising and falling patterns of the atmosphere cause the weather that we experience. We have prevailing winds. It's a very complicated system of heat and mass transfer of the fluids that move throughout the atmosphere and can eventually disperse stuff all around the world. Similarly, the oceans move over time scales more on 100 years or 200 years. The ocean circulates like a big conveyor belt around the world. The ocean in the Atlantic travels north on the surface waters. Prevailing water, the current flow is north. It reaches here in the Arctic, where it cools off and it's salty, and the water falls, comes back along the bottom of the ocean, and rises again in the Pacific to make its way back. So over longer time scales, the ocean circulates around the world. This serves as a temperature regulation device for our planet. If this ocean circulation system slowed down or stopped, it's like the hot water heating in your home. It helps regulate the temperature all around your house. When that shuts off, you're going to have hot spots here and cold spots there. Same with our Earth. This complicated system of atmosphere and oceans interact so that changes in one part of the system might be felt in an entirely different way in some other part of the system. We know from watching the news every night that patterns of weather affect us. You look on the weather report and you see that if it's a spring pattern, typical spring pattern, and the jet stream's coming across the United States, it's going to be fairly warm. You know that when we get winds that come from the Arctic, it's going to bring cold air in. It matters where our air comes from. But we have had prevailing systems of circulation around the planet that lead us to expect what the pattern will be like in each season. This is a typical spring pattern. When we go through climate change, these patterns will change. They'll change, become more erratic over time, and may possibly set up into wholly different patterns of flow that really affect our weather. They will affect us either indirectly or directly. You don't have to live near the coast to be affected by climate change. So how do we know how current climate compares to the past? You've heard about studies of tree rings, where you can count the rings to see how much was put on each year. The thickness of the ring will tell you how much rainfall was there that year, how the growing conditions were in tree rings. And that can go back many hundreds of years in some trees. We can drill ice cores in the polar regions, in the Greenland and Antarctic ice sheet. It's just like tree rings, except that instead of going out, we go down. We drill through these ice sheets that are several miles thick. And as we go down into the ice sheet, we go further in the past. We can count the layers. We can do chemical analysis. We can find out when a volcano went off. And they go, the ice cores, the oldest ice cores that we have are from Antarctica. And it's about 800,000 years into the past. We think that there's a place in Antarctica where we can get million-year-old ice. But we haven't been there yet. And that's probably the oldest ice on this planet, million years. As opposed to that, sediment cores that are taken from ocean bottoms, these big ships that go down and drill the sediment from the bottom of the ocean can go back hundreds and millions of years. So ocean sediments can go way further back in time. So each part of the environment has a different story to tell and on a different time zone. So we're on time scale. So we're going to talk today about glaciers and ice sheets as natural archives of past climate. This is me and the Greenland ice sheet. This is in a snow pit, so the snow's up here. We use the shovel to dig down. And if you dig down, Greenland is up here in the Arctic, and Antarctica is here down south. I should say at the beginning that when you look at the Arctic, you see whiteness. This whiteness here is on the Arctic Ocean. Most of the Arctic is an ocean covered by sea ice. And sea ice can be several feet to 10 feet or 12 feet thick. It might be a typical thickness. This is Greenland, and although it's white, it is much thicker ice. If you stand in the middle of the Greenland ice sheet, it's like 600 miles across. If you stand in the middle of the ice sheet, the nearest land is 2 miles away, straight down. So although it all appears white, Greenland is way different than sea ice. This is an ice sheet, and this is sea ice. So I'm going to talk about being on the ice sheet here. You dig down, and as you dig down through the snow, you notice layers in the snow. That these are deposited layers of snow that fell. We can see that the top snow here was from this year. This darker snow was from the winter before. The lighter snow below that was from the summer before that. The darker snow was winter before that. The further down you go, the further back in time you go. And so because the snow crystals are different in the summer than in the winter because they're formed under different temperature conditions, you can actually count back in time in the snow. But there's a cartoon of the ice sheet. If we are on an ice sheet that is overall 2 miles thick, the top of it is snow, like you have around here. Then the snow becomes compressed for about the top 100 meters. It's so cold there that it doesn't melt, but the snow compresses in time as more snow falls upon it. That old snow is called firn. So it's very porous. Air can diffuse down through here ever so slowly, and as you go further down in depth, you go further back in time. Finally, around 100, 120 meters or so, the snow is so compressed that it is turned into ice. And what used to be interstitial air spaces in between the snow grains, now the only remaining air is trapped in bubbles in the ice. So you can tell I drew this because I studied firn. So I, of course, the firn as being the most important part. But really, firn is the top 100 meters, and the rest of the, most of the 2 miles is here in the solid glacial ice. So we're going to use ice cores now to think about how fast climate can change. Before, about 50 years ago, climate science taught people that climate was a slow-moving beast. It took millions of years for stuff to change. Ice core science has taught us that that's not always the case, that in fact it can go much faster than that. So the data I'm going to show you here is from Greenland, and it's evidence from the ice matrix. So if we drill an ice core here, it's analysis of the counting the layers in the ice to see how much snow accumulated each year, and taking isotopes from the hydrogen and oxygen isotopes from the ice itself as an indicator of what the general temperature was in the past. So here is this plot is from Richard Alley's Two-Mile Time Machine book. But here's the current time. This is current time about 10 years ago. And this is going 15,000 years into the past. Here we have temperature. And this was general temperature at the site in Greenland. So this green plot we see is of temperature. What that is the isotopes that are a proxy for temperature. And this record, so that part of the record show here, goes back about 9,000 years. And you can see that over 9,000 years, yes, temperature has changed. The accumulation rate is here in red. That's from counting the layers and saying how much snowfall each year. So the precipitation does change in time, and the temperature does change in time. So is climate always changed in the past? Sure, but that's not the whole story. They, just to example, look at two different times. This orange time here was between about 1,000 years ago, the medieval warm period. And you see that little wee peak in temperature there? That was around between 950 and 1250. Medieval times was good times in Europe. The farming was good, the culture was growing, life was good. It was so good in Europe that Vikings and other Scandinavians started migrating to Greenland, where we got our ice core from. And they settled along the coast. You can see the remains of their settlements today, the cemeteries and the foundations of the houses that they have here. Then later, a couple of hundred years later, came what we call the Little Ice Age. And it wasn't real, there was no growth of ice, but it was a cold spell that went for a long time. And here you can see this little blip in temperature here was lower, so it was warmer in a medieval warm period and cooler in the Little Ice Age. That little change in blip was enough so that the farmers who had settled on the coast of Greenland and had their animals and had their farms could not survive. The weather got too cold for them to farm, the animals died off, and the people who didn't leave, the Scandinavians who didn't leave, eventually died off. Many of them left. The Inuit, who had always lived along the coast of Greenland, the Greenlanders, just moved to where the fishing was good and where the hunting was good. They weren't tied to that farm, so they could move to wherever they wanted. But the Europeans and Scandinavians had to leave. So we see that even that little blip is enough of a temperature change to influence the way people live. Now we're going to look back further in time. We go back further. This is between 10 and 15,000 years ago. You can see that the temperature changes are much more dramatic and much bigger. If this was enough to influence the way people live, imagine that. What we learned from the ice cores is that this change from here to there and down and back again, this steep line, happened in less than 10 years. So something happened in the climate that made a huge change in temperature. This is like a 10-degree temperature difference in less than 10 years. This makes climate change relevant to people living now, and the term of a congressman or whatever. But we learned that climate can change abruptly in less than 10 years. It turns out, if we go further into the past, climate was much more like this in the past. Some people call it an angry beast. Climate is an angry beast, meaning it can change a lot. So what caused, I can just briefly touch on this, what caused that change in climate? It was during the time when there was a Laurentide ice sheet all over the Arctic and even covering Canada and in fact covering Hanover. There was an ice sheet here at that time. We were coming out of the last ice age, so the planets revolving around the sun, the orbital change was enough to put more sun's energy. It was melting these ice sheets. And as it melted the Laurentide ice sheet, the fresh water from the ice went into the ocean and it formed a cap. Essentially, when you get this current here, as the water comes up, the surface water in the Atlantic comes up through the ocean, it gets warmer and warmer as it heads through the Americas and through the North Atlantic region. As it gets warmer, it evaporates and the water gets salty. So by the time the current gets up here and gets far enough north that it cools, now you have cold, salty water that wants to sink. So this water wants to sink. When the Laurentide ice sheet melted, it put fresh water on top that didn't want to sink. So sometimes we call this the engine of the conveyor belt. What happened was the melting of that water slowed this conveyor belt way down. That means that you got way colder in the north and way warmer at the top, just as the temperature segregated, because we don't have our heating system going here. And so it was slowed ocean circulation that made that huge change in less than 10 years. Turns out that most of human history, that of people, not of us as apes, but of people, happened in this last 10,000 years when our temperature was pretty good. So all of human development, we've been used to a pretty gentle climate. It hasn't changed that much. We haven't experienced the big changes that happened naturally in the past. All right, so I have another story from ice cores, is how do greenhouse gases compare with the past. Just as we looked at the isotopes in the ice to look at temperature, we can look at bubbles in the ice to look at past atmospheres. If you want to measure what's in the atmosphere today, you can go outside and measure it. Any place around the world. Some things are well mixed and some things aren't, but you can measure it. If you want to know what was in the atmosphere 100,000 years ago, you need to go to the ice sheet and drill down and sample the air. Sample the air from these bubbles. So this is air that is trapped in air, is paleo air. It's thousands, hundreds of thousands years old. So here's a graph of data from Antarctica that goes 10,000 years into the past. This part of the graph, these many thousand years here, where it's not changing very quickly, were before human times. Here's the present, and you can see this is carbon dioxide and here's methane. Both are greenhouse gases. So up until the industrial period, over 10,000 years, you can see it was changing pretty slowly. We got to the industrial period, and the carbon dioxide and the methane in the atmosphere shot up. It's because we're adding it to the atmosphere. It didn't happen naturally. Let's go further in the past. 10,000 years, pretty long ago. But from that ice core in Antarctica that goes past 800,000 years, here's a plot of that data. Sorry, now the current time is over here on the right, and we go 800,000 years in the past. So this is, the black is temperature, the green is methane, and the red is carbon dioxide. The first thing you notice is climate constant in time? No, it's not constant. Oh, climate has changed a lot. It changes naturally in time. It sure does. But, and that's a big but the concentrations now are way off this graph. The natural concentration of CO2 in the atmosphere over 800,000 years goes from 180 parts per million to 280, 180 to 280, 180 to 280, 180 to 280. We're up around 400. Okay. Yes, it has changed naturally in the past, but we are way out of the natural regime for greenhouse gases in our atmosphere. And you can see how closely linked the greenhouse gases and the temperature are. What caused these variations? They look fairly regular. What drove those in the past? This was way before people had any influence. Anybody know?
Well, there are a couple of things. One has to do with the tilt of the Earth's axis, and the other part of it is the elliptical shape of the orbit.
Exactly. Good. They're called the Milankovitch cycles, but the cycles that of the orbit around the sun, the Earth has a tilt that changes in time. The Earth has a wobble on its tilt, and time to make these regular cycles. So here we are now. So in the cold times, there was ice on the Earth. So where that ice came from was water from the ocean evaporated. It went to the Arctic and Antarctic. It froze. It fell as snow on the ice sheets. So during these cold times, the ice sheets were big. They covered Canada. They covered part of northern United States. During the warm times, when temperature was high, carbon dioxide was high, and the ice sheets melted, and sea level went up. So there's this balance between sea level and the size of the ice sheets that happens over time. And it's happened naturally in the past, but now we're getting way, way high, above the levels we've seen in the past. So this finding was part of the IPCC, the Intergovernmental Panel on Climate Change. When you read that the atmospheric concentrations of CO2 methane have increased to levels unprecedented in the 800,000 years, that came from the ice core data. So the scientists around the world, what they try to do is do science that is important to people and get your science to inform the IPCC, puts it all together to look at the broader perspective. So we're now conducting an experiment with our planet, putting all these greenhouse gases into the atmosphere way higher than it's ever been. Kind of scary, but I wanted to show you data that showed that humans could also improve the environment. So this is data from Greenland, and what it is these are essentially the same plot, but what it is lead. So over here, we're going to talk about the red version of it. Over here is 1800, and it's up to 1980 on the right-hand side. So that this was lead in the atmosphere. So that you can see there was a natural level of lead in the atmosphere going up to about 1850, okay, before the industrial period really got going big. Then, when the industrial period started and we were using lead in gasoline and combustion fuels, the lead in the atmosphere went up. It then came down in the 1930s. Why would the lead in the atmosphere come down in the 1930s? The Great Depression. Okay? The economic conditions meant that people could not drive as much, the industries shut down, the factories that were burning things shut down, and although it was an economically depressed time, it was actually better for the environment. There was less burning going on. But we came out of the Great Depression and started cranking up again, and we got those lead right back up again, until the Clean Air Act here in 1970. Clean Air Act was introduced, we went to unleaded gasoline, and the lead decreased. All of this was from lead scavenged from the atmosphere in snow crystals that fell on the Greenland ice sheet, got buried, and came along and became part of the ice core record for later analysis. So the thing here is that human actions, whether they're inadvertent or on purpose, whether they're from economic downturn or whether they're from policy decisions, can matter. And so it's not hopeless. There are ways to change things. So policy change is important. And I know that you are all as optimistic about our government as I am. It's good policy decisions. So I'm looking at this situation. I think that the need to reduce greenhouse gases means we cannot wait to policy, but we need to look at what other things are going on now that could help our condition. And so policy alone might not be as fast as other actions. So we go to renewable energies now. This is a special report on renewable energies, and what this is from 2008 back to, what is this, 1970s. So more modern times. This is the different renewable energies and how they have progressed through times. So this is hydropower here, the dark line. So you can see hydropower has been developed, but it's not increasing at a huge rate. We've dammed up a lot of the valleys that could be dammed up, right? On this one we have wind energy is that orange, solar is the gold, geothermal is the tan, and what is this? Municipal solid waste is this dark. So you can see use of renewable energies has been increasing, and the technology is developing to make it much better. Down here we have solar, and the rise in the capability, the technical capability of solar is huge in recent years. It's really gone up by leaps and bounds. So from that same IPCC report, they analyzed the theoretical potential of alternative energy systems. It's like, okay, do any of these have hopes of meeting our needs? So on this graph, there's geothermal energy, hydropower, ocean energy, and wind energy here as used to develop electricity. And you can see that geothermal, this red line is the global electricity demand in 2008. So this is the line we have to meet in order to make energy. The potential for geothermal is above demand. There is more geothermal sources on Earth if we could only capture those to meet the 2008 demand. Ocean fairly well straddles the line. Wind energy is above the line. There is more wind energy available if we would implement wind energy to meet the 2008 demand. Over here we have primary energy, like the primary energy source for our home. Direct solar is here on the right. Here's the 2008 level, the demand for primary energy in homes and businesses. You can see that solar is way above that. So the theoretical potential of how much sunlight is coming down is there. And we saw from the previous graph that the technology is increasing. It's getting way better. And so that spells opportunity. The resources are there. They are free. We don't have to dig them up. We don't have to transport them. They're free and they're out there. If we could learn, if we develop the engineering, the technology, it can do it. And the opportunity now is that these have developed, especially solar around here and elsewhere, has developed to the state where it is now, it doesn't make sense not to put it in. You cannot afford not to have solar. So here's the renewable energy. Of course it depends on your local environment. So from the Renewable Energy Lab, here they have this graph is the solar potential in the United States. So how much sun different areas of the United States gets. And for comparison over here is Germany, and here's Alaska. So purple means there's not as much solar energy. It's a high latitude place. Green and yellow means there's some, and red means there's a lot. So the Southwest is rich in potential solar energy. They have a very clear atmosphere. The sun shines most of the time. Very, very rich in solar atmosphere. Here we are up in the cold, dark New England in the green. And the odd thing is that Germany is way down here on the map. Germany gets way less solar energy from the sun than we have here. But Germany's been using solar panels for a long time. So being green doesn't mean it's bad. It's, even though we're not at the top of the charts, we are in an area where it is now affordable and there's enough sunlight to save us money. The same kind of map exists for wind here. This is a wind potential along the United States. You can see the central plains here are windy. The wind blows all the time. It's just incessant all the way up the central part of the country. And then there's other little spots here and there where there's some wind. But this is the big wind potential for the U.S. So even here in the cold, dark Upper Valley, technology price has now come down to a point to make it so that the homeowner, the community, the schools can save money by using the energy from the sun rather than from another source. So, and you can't help but drive around and see all these things popping up around here. So saving money, to me, it seems like most Americans are interested in saving money, whether they care about climate or not. If I tell you that you can save a lot of money on your electricity bill at home, listen, it makes a difference. But what about those who aren't concerned about climate? They have long-lasting ties to the land. They have been on that land for generations, and they don't like the looks of this stuff. I want to show just a 10-minute film clip from Polar Palooza about a farmer in the southwest United States and a community in Denmark. In Denmark, you won't be surprised probably, but the farmer owning land down in Texas, it's really interesting to hear what he says. So, is it okay if I show that for 10 minutes? Yeah. Okay.
No.
We don't want a movie.
Come on, Mary.
Turn the lights off for the video.
Judy. Judy will get it.
Are there other examples of communities and nations that have begun the transition away from
Turn the lights
fossil
off.
fuels? What does it take to welcome the turbines
Turn the lights
and
off.
solar farms of the new energy system and say, yes, in my backyard? This is the story of two communities that at first look very different. Samsa is a small island off the Danish mainland. West Texas is a vast, dry expanse in America's south. What both have is abundant wind. At times, Samsa produces more electricity than it uses, exporting surplus power to the Danish mainland. And Texas wind now generates as much power as the next 3 U.S. states combined. Samsa and West Texas both solved the NIMBY, not in my backyard challenge, that has stymied so many renewable energy projects. It's not easy, but with patience and persistence and the efforts of the right people, it can be done.
Okay. My name is Søren Hermansen, and I'm the director of the Samsø Energy Academy. Samsø means in Danish, it means the meeting island. When you make a circle around all of Denmark, then Samsø is right in the center of this circle.
But it wasn't geography that brought Lørke Friis, then Denmark's Minister of Climate and Energy, here in mid-2011. It was why and how this community had turned NIMBY into yes in my backyard.
Well, Samsø is a pioneering project in the sense that Samsø way back decided that Samsø should become independent of fossil fuels.
Before its transformation, people thought of Samsa as just a cute tourist community, busy in summer, empty and desolate in winter. Now people come here not just to see the turbines, but to understand the process that got the community to welcome wind energy. After a national competition, Samsa was selected by the Danish government to be a proof of concept for how to transition from fossil fuels. But it was up to individuals like Søren Hermansen with the passion and skills to affect change, to figure out just how.
So when we won, the normal reaction from most people was like, yeah, you can do this project, that's okay, but just leave me out of it.
Samsa has a deep attachment to its past and values its traditional way of life.
But gradually, we won their confidence in establishing easy projects to understand and also easy projects to finance, because basically it's all about what's in it for me, because it's not convinced idealist or green environmental hippies who lives here.
Søren, a native of the island, convinced some of his neighbors to become early adopters. They found success and spread the word. Jørn Tranbier operated a large and profitable herd of milk cows. After initial reservations, he invested in a turbine on his own land. When that went well, Jørn became part owner of one of the offshore turbines.
farmers, they have to invent new things and be ready for changes. So when they see potential, they look at it, no matter what it is. They look at it and say, could I do this? And if they see fellow farmers do the same thing, they're quick to respond to that. So even being very traditional and conservative in their heads, I think they have this ability of making moves and do things because they have this independency in them. A farmer is a free man. Maybe he owes a lot of money to the bank, but he's still a free man. He's thinking.
It was seeing what was in it for them and for their community that won over landowners in West Texas. And it took one of their own, a man whose family had deep roots in Roscoe's cotton fields, to educate them about wind farming.
Well, I'm really a farmer. You see, I farmed for almost 40 years. We're in the right in the middle of the Roscoe wind farm, and we've got about 780 megawatts of production. That's per hour, enough electricity for about 265,000 average homes.
Roscoe had no oil and faced hard times in the early 90s, but it did have wind.
When this land was acquired, there was absolutely no value to the wind. Fact is, it was a severe detriment because of the evaporation of the moisture.
Cliff, like CERN, had to work with his neighbors to get them ready to accept wind turbines.
The first thing farmers want to know is, well, how much is it going to cost me? Cost them nothing. What's it going to hurt? 3 to 5% of your farmland is all it's going to take up. You do what you want to with the rest of it. Then it came down to, well, how much money is this going to make me?
Cliff did his research and checked his numbers with wind experts and the Farm Bureau.
Then I was able to go to our landowner association and show them where they had been receiving $35 to $40 an acre. Then the landowners could expect somewhere in the neighborhood of 3 times that.
In fact, farmers stand to make $10,000 to $15,000 a year per turbine just from leasing the wind rights.
There was no guarantees in it from the very beginning, but sure enough, we've got, I think, in the neighborhood of 95 or more % of our area that accepted the wind farm.
In both SEMSA and West Texas, individuals saw economic benefits. But the whole community, beyond the investors and landowners, benefited too.
Because of the wind farm now and the people working in the wind industry, now we've got jobs available and opportunities for young people to come back from college or from technical school or from whatever. It's just been a godsend.
For Kim Alexander, superintendent of the Roscoe School District, that godsend translates into dollars.
In 2007, prior to the wind values coming on our tax roll, our property values were at about $65 million. And then that wind development, they jumped to approximately $400 million to $465 million.
The school district will get more than $10 million over a decade. That guaranteed revenue stream unlocked additional funding. School buildings, some dating from the 1930s, could be updated, and computer labs added.
This is an indication to me of what can be done for rural areas and will be done all the way to Canada, bringing life and prosperity and back to these rural communities that are suffering just like we have.
The same oil shop that got Brazil started on ethanol got Denmark started on manufacturing wind turbines just in time to compensate for a decline in its shipbuilding industry.
And it's also good for the economy in terms of export. I mean, 10% of Danish export comes from the clean tech area.
Energy and environment always require trade-offs, such as clear vistas versus clean energy. It's something that communities have to make time to work through. Cliff, for one, believes it's worth it.
Everything, the schools, the churches, the civic organizations, all the businesses will benefit from this. It'll increase, hopefully, our town's populations and our economics.
My granddad used to just say, not realizing he was prophetic, but you know, if we could sell the wind, we'd be wealthy. Well, who would have ever thought we'd be able to sell the wind?
For SAMHSA, Denmark, and Texas, clean energy brought economic benefits and energy security. But replacing fossil fuel emissions with wind power has other advantages.
And let's not forget, also good for climate and health as such. And that's a very important argument.
We've got a constant wind resource here that's tremendously valuable, and as opposed to oil and gas, it'll last forever, and it doesn't pollute anything.
Whoops.
It's okay.
So in that example, like the farmer in Texas, they switched, the whole area switched to wind. Who initiated the change?
Individual.
The farmer. Yeah, the local people. A few people initiated it, talked their colleagues and friends and community into it. Why did they do it? Money. What are the broader impacts?
Make jobs, create jobs.
The school is, the tax base went up because the land is more valuable now because it has wind energy. The increased tax base meant there's more money for schools, churches, civic organizations. The community is flourishing now. And what about those big ugly things? Do you think the people in Roscoe are complaining a lot about that? Not so much. So grassroots actions and financial benefits to those who are impacted by the technology enables acceptance. If somebody buys a windy spot and moves in and puts up their wind vane and the locals aren't involved and the locals don't benefit from it, you're not going to see acceptance. It's an important lesson in this, I think. Renewable energy is saving homeowners money, different kinds of energy in different parts of the United States. But I just got to say that this really made me happy to see that the power company owed me money rather than me owing them money. So individuals are important to the energy transition in their home, in their community, partnering with the technology providers to get them to bring the technology that you need. And the benefits of the lower energy prices goes to the locals, so that the people who see it, who are involved with it, get the benefits. So in summary, we're not used to climate changes. We're used to seasonal changes, which is dramatic changes, but not climate changes. And we know that climate has changed enormously in the past. We should not take gentle climate for granted. The addition of the carbon dioxide to the atmosphere now has it at levels not higher than in the last 800,000 years, and probably beyond that. So when somebody says, oh, climate changes naturally, it goes up, it goes down, it changes a lot in the past, we are way above the level of change. Usually goes 180 to 280, 180 to 280 parts per million. We're now at 400. Money drives human behavior, and it's human behavior that makes the difference. Renewable energy saves us money, whether we care about climate or not. And so actions by individuals and small groups are really important in the transition to energy. You don't have to wait for policy. We can take action now. So there's two other things I recommended reading. Both are on the web. One is the U.S. National Climate Change Assessment. Maybe you're aware of this, climate change impacts in the United States. You can download that for free from the National Climate Assessment. And then last year, the Bloomberg Foundation funded a report called Risky Business. They took the outcome of here, what is going to happen with climate change right here in the United States, and they translated that to money. They have estimates on how much it's going to cost Miami when the sea level starts rising. Huge numbers. You read this, and you cannot afford not to go alternative energy. This book was written, it's based on science, it references the science papers, and it's written for scientists and people who care about climate. This book, Risky Business, is written as economists talk to each other. It talks about investment, it talks about economic risk, talks about all of that. The risk is the risk of doing nothing about climate change. So these are really helpful things. What this shows is that it's, people say we can't afford to put scrubbers on smokestacks from coal power plants. We can't afford not to. So I want to thank you for making evidence-based decisions. You guys all do that. And I want to also thank the National Science Foundation, who funds me and funds other sciences. So
Thank you.
That's also, this is a book that my daughter sent me to read, about halfway through, as you can see. But copyrighted in 1999, so it's not totally current. But a lot of what you cover on the general basics of circulation and weather and so forth, very easy, readable way.
William Stevens, The Change in the Weather.
Yeah, it's very good.
Naomi Klein's book, This Changes Everything, is also an excellent read.
So some questions for Mary?
Yes, I live over in western Vermont, and Green Mountain Power has recently installed a huge solar panel farm with individual panels. And just in terms of, you know, a utility company like that, are we going to have to wait 8 years for that to come through for less expensive electric bills?
Well,
Is it going to take that long for them to recoup their costs?
for a company to do it to make profit, it will take longer. And I think the longer we say, how long is it going to take them, the longer it will take. But even on a smaller basis, we can do it. I bought the solar panels at my house. They cost me less than a new car. I will pay the electricity that they generate pays for the cost of those panels in 7 years. They're guaranteed for 25 years. So 8 years to 25 years, my electricity is free. So I'm not waiting for everybody else, you know? But it is time for action. And certainly federal policy, state policy could really help out a lot with the power companies. Yes?
One of the, I don't call it a drawback, but one of the problems with independent solar in Vermont, if you put it up, they have to buy it back, up to a certain limit.
Right.
Okay. Now, if you generate more than what you normally use, they won't pay you.
Oh, no. Yeah. No. The best I can do is get free electricity.
Yeah. And the other thing is that feeding that back into the grid system, okay, does cost the carrier something, which tends to drive up the unit cost per kilowatt hour for the rest of the uses on the system. And that's one of the issues. It's an educational thing, because the population out there that doesn't have the means to install solar, or can't afford to do cars, they're saying, well, yeah, you're getting free electrical, we're going to recover the cost in, say, 10 years, but I'm helping to pay your bill because my power cost is higher.
Well, actually, the money that I pay to buy electricity, I pay more per kilowatt hour to buy from the grid than they give me when I sell to the grid. So it's not an even change. And if I use more, when you get solar, they size it for your annual average use. So it's sized per house. If you don't use as much, you don't need as
The
many.
reason is that in Florida, that argument about the power company says that every time you hook up to the grid with a home power solar system, it costs me money as a power unit, power company, and the distribution and so forth. And right now, Vermont generates a higher percentage of its total power usage from solar than Florida does.
Yeah. Well, Vermont
Florida
has
makes
better
it
state
difficult
policy.
to have solar,
Yeah.
which is ludicrous.
But the reason, I mean, there's other factors and they're very tiny if that comes out in the wash at all. The real reason that energy prices are going up is like Vermont Yankee shut down. We shut down other sources of energy. So of course that's going to change the cost.
But like I said, I think it's more of an educational issue, to things like this.
Yeah.
Make sure that people understand that
Yeah.
it has more benefits than just money.
Yeah.
Yeah, I think what you're saying is somebody has to maintain the grid. And that's expensive. And that has to be done fairly, and that hasn't been done yet, as far as I can tell. There were some complaints, a low-income advocate was talking on BPR a number of months ago about this problem. And most of the solar installations are high-income people. And they're not paying their fair share, according to this fellow, about...
That
actually is not, that's not accurate.
I would like to see an evidence-based argument and the numbers for that. It's hard for me to believe that.
Yeah, I can't vouch for the numbers
Okay,
at
go
all.
ahead.
Actually, there have been a lot of studies of the cost of solar to the grid, and it varies. It's very specific to the situation. Each utility has different generating plants and different transmission line needs and different development plans. So it depends, but Vermont's study found that it was slightly below the, it was costing the utilities a slight amount to actually being a benefit for the utilities. Massachusetts, I think it was the value of the kilowatt hour that solar generated to the grid was around 22 cents. In Maine, just did a study where they pegged it, including all the social benefits and health benefits, at around 33 cents a kilowatt hour. So it is profitable. It does benefit the grid.
Nationwide, in science and in engineering, is a huge effort on studying the infrastructure and the grid system in the United States. We're in need of some change anyhow. And so making those and efficiencies and trade-offs of how to switch different, channel different energy systems.
Yeah, you mentioned several of the benefits of using renewable energy. And there are lots more of them. One of them is the health benefits of not burning coal-fired power plants in New Hampshire.
Right.
Or the benefits of national security. We're not dependent upon oil from the Middle East. There are lots of benefits that aren't just the dollar and cent.
That's right, that's right.
That's part of the educational issue,
Yeah,
because the low-income family living in a tenement, those, not necessarily tangible benefits, don't help him pay the rent, and don't help him feed his kids. And that's, you've got to really do almost as much in terms of bringing the cost down for solar and wind and so forth, as you do on educating the general population on what the benefits are. And I think we're doing pretty good on the technology side. I just don't believe we're doing as good as we need to do on the educational side.
I agree. I agree, and I think we need a fact-based, take the whole argument in, because I'm sure it would come out on top, yes.
On the educational side, what I'm doing here tonight is streaming this live to who knows how many people out on the internet watching this presentation, and recording it, and it will go out on YouTube, so you can refer people to it so they can see this and experience it.
Nobody would say something wrong.
That's why I didn't say anything before, so she wouldn't panic.
Yeah.
I have a question. If this works so well, why don't they use it for manufacturing? I mean, if it saves money, can they produce enough energy for these methods for manufacturing? Why do we hear so much about China burning coal?
Well, China's actually making, I mean, they have a huge amount of coal, but they also are making huge strides in scrubbers for coal power plants, and they have invested more in alternative energies than the U.S. has. So yeah, it has to be scaled up, and clearly, I mean, if you have massive operations like massive wind farms along that belt in central United States, they could provide power. You need the grid to take it out from there. So the form of energy you use depends where you are and what's available. get there for industry, but it's not.
Did you have any tax credits on your installation? I thought they were available, and isn't that policy?
Yeah, it's old policy, but it's there. There's a federal tax, there's a small state tax credit, but there's a federal tax credit for homeowners or people who own houses who own vacation homes. If you install any kind, it's nationwide, if you install any kind of alternative energy, you can deduct a third the cost of that unit from your yearly taxes. So the government isn't paying you back, but you give the government less money. They allow you to deduct that for 1 year. And that's a huge incentive. That's why, I mean, my husband is a physicist, and he's been lobbying to put a nuclear power plant in our yard. It's just like, so we've been having this going on, and every city is just like, oh my God, this solar tax credit, or the renewable tax credit expires in 2016. So we have this year, and then it expires, and that's it. So in my class at Dartmouth, I teach climate change and engineering, and I had Bill Bender in to talk to my class. So Bill Bender is the president of SolarFlect. There's solar panels that move around and stuff. And had him talk about, what was I just lost my train of thought. Talk about the tax credit. And as, you might think that the president of a really cool solar company might be an engineer. He's not an engineer. He has a PhD in something. What do you think it's in? Economics. He knows what he's doing. Economics. And he told my class, the class said the same thing. What about when the tax credits go down? In 2016, if the federal government decides not to give the tax credits anymore, he is designing his business so that by that time, his panels will cost that much less, so that the homeowner would end up paying the same thing without the tax.
Defensively knew what Bernie would be president.
Not sure whether that's a good thing or a bad thing.
Yes.
One of the things that's really helped a lot of Vermonters is the weatherization programs done by Efficiency Vermont. I heard an alarming thing on the radio this evening where it said the governor is interfering with the budget and is trying to get people in the House and Senate to change the budget and take away the weatherization, the funding for weatherization. So I think that isn't a very important policy issue that we maybe could have an impact on.
State policy, definitely. Steve.
I have a political observation that sort of follows that. Norwich, the municipality, is 100% solar driven in terms of its electricity. And if you vote yes on Articles 1 and 2, you'll get a building that is net zero ready and be solar powered and have a zero greenhouse climate impact. So.
All right.
Political option for New Hampshire. I love it. Which would you rather have in your backyard? Solar panel, a wind tower, or a casino?
Casino. Look at the final word. No, I